up. We're on page 311. We're continuing our proofs on the converse of parallel line theorems, like alternate interior angles are congruent. That means the lines are parallel, but we can switch them. We can say if the lines are parallel, then the alternate interior angles are congruent. One of them is the converse. One of them is the original statement. Which one? Which one? I hope you have been working on your note cards. For example, the same side interior angles, that I believe was page 311. So if you will, we're on page 312. 312, I need to make a correction there. So we're on page 312. We're going to be using given. We're going to be using congruent supplements. We're going to be using linear pair postulate. We're going to be using the transitive property. We're going to be using alternate interior angles. Maybe, maybe not, I don't know. We're going to be using alternate exterior angles. Put that one in the pile. We're going to be talking about same side exterior angles. And then we're going to be talking about corresponding angles. Have those cards ready to go. Have something to write with, have something to write on. And this video brought to you by the vocabulary words transversal and vertical angles. And on a side note, linear pair. Thank you for watching. Let's get into it. So page 311, it starts up by saying write the converse of the alternate exterior angles theorem. So let's find that card. And on the back of that card, we should have the statement. If a transversal intersects two parallel lines, then the alternate exterior angles are congruent. And that is absolutely true. The part of this statement that happens after the word then is going to become first. The part of this sentence that is in the beginning, right after the word if, that will become the then when we switch it around and write the converse. Now notice it kind of reads a little bit differently, but it still is a switcheroo from where it was before. If a transversal intersects two lines, creating congruent alternate exterior angles, then that means the lines are parallel. That's the whole point of this section. We're trying to show how we can demonstrate that lines are parallel when you flip things around. And so that's a flip around of this one. What was the then becomes the if. What was the if becomes a then. Let's get into this question. So this question asks us to write the converse of the alternate exterior angles theorem, to draw a diagram, and to write a proof. And so I've given you all of the phraseology that you're going to need to know, and we're going to fill in the blanks together. And I'll kind of keep my face, yay, a little off camera, yay, and let's get into this one. Let's go. So I drew parallel lines. Well, honestly, I don't know they're parallel yet. I drew lines, and I crossed them by a transversal. And this is also the diagram from, the previous page, page 309. So if you get stuck, turn back to page 309, and you can use that same example. Okay, let's label. So given that angle 1 and angle 8 are congruent, right? That's the key thing that we need to say. So given that angle 1 is congruent to angle 8. We know this because they are congruent alternate exterior angles. We're allowed to assume from the beginning we've got congruent angles. So then consider that angle 1 and angle 4 have to also be congruent because, well, okay, wait. Do I have it in my list? I might need to go find it. When you look at angle 1 and angle 4, let me bring my face back in here for a minute. Angle 1 and angle 4 happen to be vertical angles. They're created when two lines cross. They're on angles that are across from each other. So therefore, angle 1 and angle 4 are vertical angles. And by the vertical angles theorem, we know that vertical angles are congruent. All right, well then that means that angle 4 is congruent to angle 8. Because if you happen to have angles that are matching, but like they need to switch, right? You have angle 1 and angle 8 are the same. You have angle 1 and angle 4 are the same. Angle 1 is common to both of these statements. Since angle 1 is in two places, take it out. What are we left with? Angle 4 and angle 8. That's the transitive property. If A, B, and C are real numbers, A equals B and B equals C, then A equals C. It's the part in the middle, and we save transitive property for congruence. Okay, let's keep going. But, mind you, angle 4 and angle 8 are congruent because they are corresponding. So angle 4 opens but it's on the inside. And angle 8 opens, but it's on the inside. Reminder, by the way, part of our vocabulary words is corresponding. One of our vocab words for you to make sure that you've memorized. Now, if they're corresponding, then that means that our line, we need to name the line here. Let's name this W and name this X. It's cut by transversal Z. Then that means that W is parallel to X because of the corresponding angles converse theorem. Let's see if I have that one ready to show you. Yeah, corresponding angles. You take your if-thens and you switch them. If the angles are congruent, then the lines are parallel. That's the first part. Let's get to the last one, right? Part B. Write the converse of the same side exterior angles theorem, draw a diagram, and write a paragraph proof. Okay, so the same side exterior angles theorem, we're going to go ahead and flip it around. If a transversal intersects two parallel lines. That's the if-then on the card with the way that it's written. Then the same side exterior angles are supplementary. Like that's how we would read that. And we have some examples here. But when you write the converse switches these two statements around. And so the converse has the if going second and the then going last. If a transversal intersects two lines and creates supplementary same side exterior angles, that's really like a re-speak of what's going on in pink, because we want to save the word parallel for the then section. All right? Then the lines are parallel. Now I've recreated the diagram from the previous page. Feel free to flip back and take a look, right? It's that diagram. We recreated it for both of these, but I'm talking about same side exterior angles now. And let's specifically focus on angle 1 and angle 7. All right, we're going to say that we know from the beginning, let's use a different color. We know from the beginning that angle 1 and angle 7 are congruent. And I can say as my given, right? Every proof has to have a given statement. It's what we're allowed to start with. That, I can use that right here. Angle 1 and angle 7 are supplementary. We know they're supplementary because that's what happens with same side exterior angles. They are supplementary. But you know, if you're thinking about it, angle, where are we at here? Angle 2. I'm still trying to like get my bearings here. Angle 1 and angle 2. Oh, that's right. Angle 1 and angle 2 are supplementary, right? So angle 1 and angle 2 are also, right? They're supplementary because they form a linear pair. Boom, there it is. They form a linear pair. By the congruent supplements theorem, we've used that one an awful lot. By the congruent supplements theorem, that means that, well, they both have angle 1 in common. I know I highlighted it green in the last one, so I'm going to highlight it green again. Because there's an angle that's in common with both, then angle 7 and angle 2 must be congruent. It's congruent because of congruent supplements theorem, right? We have this situation where we got two angles. They happen to be equal to another angle, and so therefore they're equal to each other. We've also used congruent supplements on page 312. Okay, so the lines are parallel. Label it. You label it W, label it X, transversal Z. W is parallel to X because of the converse of the alternate exterior angles theorem. You know what? We just had the alternate exterior angles proof right up above in this problem. And once you've proven something, that now becomes a shortcut for you to use from that point on. So noticing that 2 and 7 are congruent alternate exterior angles, and that was enough to prove the lines are parallel, then we get to shortcut all of the extra words that could be said and just use that to say W and X are parallel lines. You guys, please take your note cards. Please take the theorem, the alternate exterior angles theorem, the converse, and take the same side exterior angles converse and add them to your note cards, or at least comment on where else you've seen them, like we saw this on page 312. All right. Thank you so much for watching this video. We are continuing to talk about things that we learned, things that we saw from the information at hand. So I'll see you in the next one. Thank you for learning about some of these parallel line proofs. Thank you.